Hey guys, so let's discuss this problem. As always, we are going to start with the example here. So we are going to have three test cases, and each of the test cases will have the first number is the number of graphs, the number of nodes in a graph. It is going to be a complete graph. So, for example, the second test case, we are going to have three nodes, one, two, three, and it will have uh, directional edges between all of these nodes and form a complete graph. Complete graph means that there are two edges in the opposite direction for each of the two nodes, right? So this is a complete graph. And we are going to start at any of the node. And the goal is to travel through all of the edges and arriving at the same point where you get started, right? That is a circle. Let's see if we travel from this edge to this edge and to this edge and to this edge, this edge, this edge. We back to the start point. That's a circle, right? And we are going to record the nodes we traveled through, right? Let's say we start from the first node and traverse this edge, and we arrive at node 2 and go to node 3, go to node 1 again, and go to node 3, go to node 2, and end up in node 1, right? That's a circle, and we can get a string constructed by all of those nodes we traveled, right? And our goal is to fi find a circle that construct a string that is lexicographically smallest. What does that mean? So, for example, if we are going to compare two streams uh, lexicographically, for example, let's compare this string. So which one is smaller? So we are going to start from the leftmost character, right? They are equal to each other. So we move on to the next. Still equal to each other. So move on to next. So for this character, this guy is smaller than this guy. So this string is lexicographically smaller. So how do we find the lexicographically smallest string constructed by the circle here? So we are going to use greedy algorithm, right? So the first starting point, of course, will be node 1 because we have to make sure that the leftmost character is the smallest one, right? And what is going to be the second node we travel? Do we travel to 2 or node 3? Of course, we are going to travel to node 2, right? Because if we travel to node 3, this guy is smaller than this guy, then this string is going to be lexicographically smaller, right? So we are going to choose the smallest number connected to the starting point. And then which way are we going? So are we going back to 1 or to 3? We are going to 3, right? Because if we're going back to 1, Actually, we are going back to 1, right? Because this is the small, this will be the smallest string we can construct it. 1 will be the third character, right? And what are we going then? We're going to, so we have only one option here, that is going 3, because we already traveled this edge, right? So we go to 3. And then 3 has two options, going back to 1 and going back to 2, right? Which way is it going? So can we going back to 1? No. The reason is because if we going back to 1, then three, these four, these two edges connected to 1 are already traveled, right? So that we, in this circle, we cannot travel these two edges, right? So we have to travel all of the edges. So we cannot go back to 1 here. So that left us only one option, which is going to 2, right? And we arrive at 2. Can we go to 1? No, because we already traveled this edge. So we go back to 3. And then where are we going? We are going back to 1. And this forms a full circle, right? Cool. That is the smallest um, string we can construct, right? And then what is the second and the third number? That is the range of our output, right? So we are going to output the third character in the string to the sixth character in the string, which is from this guy to 3, 4, 5, 6 to this guy, right? So 1, 3, 2, 3 is our output. So we have this output here. So how are we going to solve this problem? So first, we need to make sure that we form a circle. Second, we need to make sure that we travel all of those edges. Third, we have to make sure that the constructed string is lexicographically smallest. So how can we do that? First, we can just make some examples here to see if we can find the pattern, right? Let's see. So for the output, if our n equals 2, this is the output, right? Because we are going to have a graph like this, and we are going to travel from 1 to 2 and back to 1. So this is the first output. And this is the output for 3. We already discussed before, right? And what is the output for 4? This is the output for 4. And if you try yourself, this is the output for 5. So can we find the pattern here? The answer is yes. Let's see, why does this stream looks like this? That is because this guy is obvious, right? For the node of 4, let's draw the graph here. For the node of 4, we are still going to start with 1, right? And now we have 3 options. Of course, we are going to choose the smallest next node, right? So we go to 2. And then the next node is, of course, 1, right? Because we need to choose the smallest node. And then the next option is 3, because still we want to choose the smallest node we can go, right? But we already traveled the edge connected to 2, right? So we go to the node 3, then go back and travel to node 4, right? Now Here we cannot travel back to 1 because if we travel back to 1, we cannot cover a lot of other edges, right? Because all of the outer edges of 1 is used. So we need to go to the next smallest node, which is 2 here, right? And then when we are arrive 2, we need to go to 1, 3, 4. But we already used the 1 here, so we go to 3. And then we go back to 2. Now we go to 4, right? Now we cannot go back to 2 now, right? Because we already traveled the 4, 2 edge, right? So we need to go to 3. And then we can go to, from 3, we can only go to 4 now, right? And from 4, we can go back to the original point. So that if that makes sense, we can just repeat the process for n equals to 5, and we can get this. And we can find some pattern here. So as we can see, the number of the, as we can see, there is a starting point for each section here. So we break the stream into several sections. And for each stream, if n equals 2, then we have 2 sections. If n equals to 3, we are going to have 3 sections, right? So that's the first pattern. And the second pattern is that for the first section, we are going to have n minus 1 multiplied by 2 numbers, right? The first section for 2 is has 2 numbers, and the first section for 3 has 4 numbers, and we'll increase them by 2 for one more n, right? So that's the second. And the third pattern is that for each section that follows the first section, the number of numbers will be decreased by 2, right? For example, the first, actually, let's see. Yeah, except for the last section. The sections before the last section will be 2 numbers less than the previous section, right? So this section is 4, so this section is 2. This section is 6, so this section is 4, and this section is 2. So on, right? That's third pattern. And the fourth pattern is that for each section, there will be a starting number, right? So the starting number for section 1 is 1. The starting number for section 2 is 2, right? And the starting number in each section will be repeated by the number of in the section divide 2, right? And appears at all the locations, right? As we can see, 1 appears here, 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 and 2 appears here, here, and 3 appears here, right? And we can see the second number will be 1 more than the starting number, and the fourth number will increase by 1. The third number will increase by another 1, right? So as for this one, 3 is a 1 is bigger than 2 by 1, and 4 is bigger than 3 by 1, right? So with those being said, we can easily construct algorithms to form this kind of streams. So let's take a look at the code here. So first we are going to read the number of test cases and read NLR, right? And we are going to iterate from the first section to the last and calculate the stream for each section, right? This is where we calculate the stream and output the numbers, right? And for each section, the count here is the number of numbers in that section, right? For example, for the first section, there going to be how many numbers? N minus 1 multiplied by 2 numbers, right? And um, start here means the start number of the section, right? And cur here is the current index of the starting point, right? For example, at the first section, the first number is at index 1, right? And 1, 2, 3, 4, 5. And the first number of the second section is at index 5, right? So cur is the index. And we are going to construct the section here. And first, if the start equals to n, then we print 1, right? Because for the last section, we always travel back to the original point and output 1. And if current index is bigger than r, that means the 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 location, the index we are at is bigger than the range we are going to output. So we don't need to go on anymore, right? And this part is to check if current index plus the number of numbers in this section is bigger than L, right? If it is smaller than L, that means the current section, let's say this is the current section, and this is the L and R, right? So if current section is at the left side of the output range, we don't need to calculate this part of string, right? So let's move on. P here is a pointer which pointed to the which number we are going to use after the first number of this section, right? We are going to use 2, 3, 4, 5, 6, right? 2, 3, 4, 5, 6, right? And its start is going to switch back and forth between 1 and minus 1. If it is equal to 1, that means we are going to add a number the same as the starting number, right? And if it is minus 1, then it means we are going to output the pointer we just talked about, right? So this is where we check if it is going to be a start number or a p number, right? If it is a p number, we are going to increase the p by 1. And we are going to switch it starts each time, right? So with this, we output the string, right? And this part is just make sure that we only output those characters in the output range, right? And we are going to do this for all of those test cases. So that's it. Thank you for watching. See you next time.